This is our final video for the week. This one should be the shortest. This is always everybody's favorite method. It is the easiest method for solving, especially if you can use Desmos. So this also kind of puts into perspective what it is we've been doing algebraically and why we've been writing our answers the way that we have. So the last way to solve a system of equations is to graph both equations. And what makes this so easy is that the intersection of the two lines is our answer. So the intersection of the two lines is the solution. So we've been writing all of our solutions as coordinates, and it's because in all of those problems, if we had graphed both of the lines, the point where the two lines cross, those coordinates that we gave, would be that intersection point. If you are using Desmos, so keep this in mind when you get to your common assessment, it doesn't matter what form the equations are in, right? Desmos will graph anything regardless of the setup. So solving systems of equations using Desmos is about as easy as it gets. For the notes for this lesson, though, we're going to talk about what that looks like on paper. And so if you choose to do either of the two, well, any of the assignments that involve graphing, you would need to graph by hand. So kind of talking about this through the situation of if we had to graph it by hand, when would you want to use this? And example 1 here is a prime example of when it would be best to use graphing, because both of our equations are already in slope-intercept form. So super easy to graph equations that are already in slope-intercept form, find that intersection point, and move on. So for this first example, we have a slope of -1/3, and we have a y-intercept of 6. So I'm going to graph this equation. I've got my y-intercept. I'm going down 1 and over 3. And I have a feeling trying to graph a straight line on the screen is not going to be the easiest thing I've ever done. But there we go. So that's our first equation. Our second one is in slope-intercept form. This time we have a slope of +2/3 and a y-intercept of 3. So starting at 3, going up 2 and over 3. And I can already see where the two lines are going to intersect. So this point right here is my solution. And so when I go to write the answer, I need to write the coordinates of that intersection point. So 3, 5. And that's my solution. So we're also going to start to talk a little bit in this section about what do the graphs look like and the number of solutions based off the graph. So if the equations create one intersection point, like in this situation, this system of equations has one solution. The other situations we may run into are that there are no solutions or infinitely many solutions. So there's really only 3 options, just like there were with one equation with one variable. In this next one, the first line is y = mx plus b. It's all set up to be able to graph nice and easy. We have a slope of -1 and a y-intercept of 3. So we're going to go ahead and put this one on the graph. My hand keeps hitting that. I don't think it likes it when I draw a circle. Okay. So here's this first line. Try to make it straight. And when you're doing these in class, I do have rulers to give you that straight edge. Our second equation is not in slope-intercept form. I need to solve this for y by subtracting 2x from both sides. So this one is going to become y = 2x plus 1. Remember, we rearranged so that the x term comes first. So the second equation has a slope of negative 2, meaning I'm going down 2 over 1, and a y-intercept of 1. Down 2 over 1. Do a few points in the other direction. It's going to help me find that intersection that's right there. And so right here was my intersection. Well, it was supposed to be if I could draw straight lines on the screen. And so the solution is negative 2, 5. Okay, so this one also has one solution. All right, in our last two, we're going to get into the situations where we have infinitely many and no solutions. So in this, again, the first equation is ready for us. We have a slope of 2 and a y-intercept of negative 2. So I'm graphing a line that has a y-intercept of negative 2 and is going up 2. Sorry, guys. It's going up 2 over 1. So up 2 over 1. I guess when I hold it down or do the circle, it pops that up, but all right, so there we go, kind of straight. There's our first line. Our second equation isn't ready for us to graph because the y still has a 2 in front of it. So when we divide everything by 2, to get rid of that, this equation becomes y equals 2x minus 2, which happens to be the exact same equation as the first one. So this would graph the same line. When this happens, when the two lines are the exactly same line, that means that they share every single point. The two lines are laying right on top of each other. And so this is what it looks like graphically when the answer is infinitely many solutions. So if your two equations create the same line, the answer is infinitely many solutions. And our last example is going to make us work the most to see what these equations are. For the first one, we've got to get x by itself by subtracting 3x from both sides. So y is equal to negative 3x plus 2. So in this equation, we have a slope of negative 3 and a y-intercept of positive 2. So starting at positive 2, going down 3 and over 1. So that creates this line here. Oh, that one's a pretty good one. Getting a little better with drawing lines. Our second equation, we're going to need to get rid of this 4 and rearrange these two terms over here so that the x term comes first. So that cancels out. Y is equal, now I'm going to go ahead and rewrite this as I'm simplifying. So negative 12x divided by 4 is going to be negative 3x, and 12 divided by 4 is going to be positive 3. So I'm noticing this equation also has a slope of negative 3, but it has a y-intercept of 3, not 2. So, well, it kind of looks like my first line already went through there, but it was supposed to go through here. And this is why rulers are important when we're drawing. So what we're going to find in this situation is that we have a line with the same slope, different y-intercepts, and what we learned in the last unit is that when the two lines have the same slope, that means that they're parallel. So when there is no solution, you're looking at a situation where the two lines are parallel to each other. They have no points in common, ever. They're never going to get any closer. They're never going to get any farther apart. And so therefore, parallel lines give us no solution. There are no values that are going to make both equations balanced at the same time. So Now graphically, you can see how to check your answers. You could always type the two equations into Desmos and see where they intersect, and that should match the work that you did either with elimination or substitution. If they intersect, that means you have one solution. If they are the same line, you have infinitely many solutions. And if they are parallel lines, you have no solution. So at this point, you are ready to try any assignments on the choice board. The spicy assignments are considered spicy because you have to figure out which method would be the best method for solution, whereas all the mild and mediums, you're told which method to use. So that's what makes those spicy. It's not that the problems themselves are all that difficult. And you need 9 points by the start of class on Tuesday. So we have a little bit longer, but you do need more points. There is no mastery check on this lesson.